This video describes the new turning feature offset, now available in ESPRIT. Turning feature offset lets you modify individual elements of turning feature geometry. Each element of the turning feature can be shifted radially or axially. Use this selective offset to program center tolerance in cases of unilateral tolerance, or to apply standard ISO code tolerances. You can also use turning feature offsets to leave material for subsequent processes without having to modify the geometry. Selective offset gives you great flexibility to program faster and more precisely. To get started, we review the product manufacturing information included in this pinion. The side of this part, with the toothed shaft, calls out a unilateral tolerance on the 20 mm diameter. This 18.01 diameter calls out an ISO tolerance of H7. For this tight tolerance, we will leave some material here for a subsequent grinding operation. The splined shaft calls out another ISO tolerance of H7 for the 12.67 diameter. This part is programmed without consideration of the product manufacturing information. To program the center tolerances, select the Selective Offset command from the Feature tab. To offset an element of the turning feature, select the feature element. And set the radial offset. Since the PMI specifies a unilateral tolerance of -0 plus 0.05 here, we set the radial offset to 0.025 and click Apply. ESPRIT retains the initial feature. You can re-edit it at any time during your program. By clicking again on the feature element, you can see the result offset in green and the initial offset in bright green. You can also use the radial offset calculator to automatically calculate the diameter and offset the element accordingly. You can calculate it by a target diameter or an ISO tolerance. To calculate a radial offset by target diameter, select a feature element. Set the radial offset calculator to target diameter. Select the element as a reference diameter. To allow for the subsequent grinding operation, we set the target diameter to 18.2. Note that ESPRIT automatically calculates the necessary radial offset. Click Apply. To use the radial offset calculator by ISO tolerance, select a feature element. Then set the radial offset calculator to ISO tolerance. Select the element as reference diameter and set the ISO tolerance. If you set Adjust to Mean to No based on your reference diameter and your ISO tolerance, ESPRIT automatically calculates a recommended target tolerance and displays the upper and lower tolerances. Because ESPRIT automatically applies the correct tolerance values based on the ISO specification, there is no need to look up the tolerance values. You can then change the target tolerance value to the desired value between the upper and lower tolerances. If you set Adjust to Mean to Yes, ESPRIT automatically sets the target tolerance in the middle of the lower and upper tolerances of the ISO tolerance. In our case, we choose to adjust our tolerance to the mean. And note again that ESPRIT automatically calculates the radial offset based on the ISO tolerance definition. Click Apply and then click Exit to close the command. The offset element appears as a dotted line. Rebuild the operations to see your new toolpath. Use the selective offset to program center tolerance for each element of a turning feature and to leave material for subsequent processes without modifying the geometry. Selective offset gives you great flexibility to program faster and more precisely. Thank you for watching this ESPRIT product feature video. For more information about this and other new features in ESPRIT, refer to the release bulletin and product help.